Hi, this is Leetcode question. Minimum score of a path between two cities, and this is the third question of weekly contest 322. So you are giving nodes, and each node represents a city. These nodes number from 1 to n, and in this case, in this graph, the nodes are from 1 to 6, so we have 6 nodes: 1, 2, 3, 4, 5, 6. Each two cities, or each two nodes connected by a road that has distance. So this value in the red is the distance between two cities, and as you can see here, the graph can be disconnected. And if we have path between two cities, for example, the path is between city 1 and 2, can be 1, this path here, then here, 1, 4, 2, this path, and the edges on this path, the edges value are 7 and 5. So the minimum value of any edges in this path is 5. There is another path between 1 and 4, which is this one directly, 1, 2, and the edges visited in this case is 9. So this is the minimum of this path. And there are other paths. For example, you can go from 1 to 4 to 2 to 6, then return back to 2. So 1, 4, 2, 6, and the edges values visited are 7, 5, and 6, then return backs also 6. So the minimum value here is 5. Also, you can go from 1 to 6, then return back, and in this case the minimum value is 6. And as you can see, the minimum value of any path between 1 and 2, or the minimum of among all the paths between city 1 and 2, is the value 5. And so how can we calculate this? In the question, what is required is to calculate the minimum of the paths, or the minimum value when we travel from node 1 to node n, and in this case from 1 to 6. So we need to check all the paths and find the minimum edge, which in this case will be 5. Notice that the minimum edge in the whole graph is 1, but here we cannot reach from the starting node, so this will not be included in the answer. So how can we find this number 5? The idea is we need to do DFS from the starting node and travel to all possible paths and by this we covered all the edges. So the idea is to visit all the edges in this group and find the minimum value among all of these edges, 6, 9, 5, and 7. So the answer will be 5. And so this will be our approach. Notice that again you cannot take the minimum among all the edges, 1, because maybe you cannot reach the destination through that edge. But what we need to do is only to check this group of nodes that are connected, and as the question says, it's guaranteed that there is at least one path from 1 to n. So here also this is the same, the output will be 5, and in this example node 1 we need to reach 4. The answer will be 2, because you can come here 1 to 2, return back, go to 3, and go to 4. So every node in this group is reachable from starting point. Then the answer will be the minimum of these edges. So this is the implementation. So you are given the vector of rows and the number of nodes. First of all, we need to build the graph, and notice here it's n plus 1 because the nodes index are from 1 to n. So this is the adjacent list for that represent our graph, and also we need to store a dictionary for every edge value. So here we store the adjacent list for every node, and here we also store for every edge what is the value, so that we can return the value in constant time, or in this case it's map, so it's login time. Here we have visited array of boolean, and it's initially false. This is for if we check for some nodes, it means that we checked all the edges connected to that nodes, and no need to check again. This is our DFS, and we start by calling node 1, and if the node is visited we return, otherwise we set it to true, so next time it will not be visited. And we check for all neighbors. For every neighbor we return the distance value between this node and the neighbor, and we compare it to our answer. Here we pass it by reference, and at the end we will have the minimum value among all of these edges.